So we have finished about kind of single machines things. Let's talk about scaling to handle large amount of traffic or data. Scaling. There are two kinds of scaling. Vertical scaling to increase large, faster CPU or large memory, large disk, and then is the horizontal scaling to have distributed machines in maybe multiple data centers. And usually in current world, the horizontal scaling is much more popular because vertical scaling there's hard limitation for that. You cannot increase the memory or disk to very large because there's on there's some limitation for that. So we will go deeper about the horizontal scaling. So first part, let's talk about how could we distribute the traffic in here. We can use load balancer. So what is load balancer? Let's see, we have this situation. We have some client, which is the user, maybe it's a computer from some website, or maybe it's a phone from some iOS or Android mobile app. And let's see, we discussed sometimes before we have some server in the backend, but this time we can have multiple servers, and between them we can have some load balancer to distribute this request and response. That is load balancer. Load balancer. So when a request sent to our server is still can be a public website or the IP address. Let's say the IP address is 1.1.1, and then it will distribute it to multiple server by this load balancer to a private IP address. Let's say it's 1, it's 2, it's 3, it's n maybe. And usually there are different algorithms for load balancer. The simplest one is called Robin Run, I think. That will just forward the request first to server 1 and second request to server 2 and to server 3, etc. But we can also have more complex algorithm for load balancer. We will not talk about it in this time. So currently we have the scaling in this server side. We can have load balancer to scale up to increase the server in backend, or maybe sometimes we don't need that so much amount. We can also easily scale it down to light server. But remember, we also have a database which connects between the server, the backend service. So how could we scale up in the database? Usually we can use called master slave model for that. We can have a master node. We can have also multiple slave nodes. And so usually the data, if it's right, we will send to master data. So the master data will contain all the data and up to date. And if it's a write request, read only, we will send to slave. We can have multiple slave database server node in here, because usually the read request is much higher than the write request, maybe 10 times or 5 times higher than the rest. So we can have more slave nodes to handle the write request. And between the master and slave nodes, they can kind of scan up which codes the database replication. They can regularly scan up. So some advantage for that. First one, better performance, because you can separate the write and read. You can have multiple slave nodes handle high amount of read requests. Also, you can improve the reliability, because you don't have the single point failure. If you only have one database node, if that's down, the whole service is down. Also, that also means it's high availability for that. So after this, we can independently scale up and scale down for database. We can also scale up and scale down for the backend servers, right? And also, there is a third topic that we can discuss about, which is code cache. So there are a lot of write than the read than the write. So what if we can cache some popular data in the cache, maybe in the memory? Let's say we can have a cache. So the server, if it's a write request, we can check if it's in the cache or not the first. And if not, then we'll query from the slave nodes and update to cache. If it's already in cache, then we don't need to send a request to the database. So usually cache is in the memory, and this is in the disk. Memory is much higher speed than the disk. I don't really remember, but I think it would be like 100 times faster than that. Yeah. And also talk about cache, you need to consider when to use the cache. Usually if you have a lot of read than write, you use cache. Also you need think about the expiration policy when the data is expired, because memory, although it's fast, this is slow, disk is slow, but memory is also smaller space than the disk, right? So you have really limited spaces. You need to expire some data regularly. And also you need to kind of update, scale up them together. That's called consistency. Finally, usually in some websites there are some static data, like the CSS data or some picture image, which is always like that. We don't really need to calculate. It always show like that. So we can handle this static data to code CDN, which means the content delivery network. You can put the static data, image, CSS, JavaScript, etc., to a CDN server. So then, if this one needs some static data, we will send the request to CDN server. Firstly, and CDN server can base on the location, so it will be much faster than request to the backend. That is at this part.